In this video, we'll talk about some word problems related to angle of elevation and angle of depression. So let's work through a few examples. Our first example says, Andy is standing 12 feet away from a flagpole. He measures the angle of elevation to the top of the flagpole to be 53 degrees. How tall is the flagpole? So let's draw the situation here. Let's say we have this flagpole. Andy is standing 12 feet away. So here's Andy over here. He's 12 feet from the flagpole. And it says he measures the angle of elevation to the top of the flagpole. So from here, this angle to the top of the flagpole, he says, is 53 degrees. We want to figure out how tall is this flagpole. So let's call this H. What is H? How tall is this flagpole? So using only this information that we're given, that Andy's 12 feet away and that the angle of elevation is 53 degrees, how can we solve for H? Well, we'll have to use our trigonometric functions. So if you'll recall, the acronym that we can use is SOHCAHTOA. And this acronym describes how we can calculate the sine, cosine, or tangent of an angle. So to calculate the sine of an angle, we take the opposite side divided by the hypotenuse. To calculate the cosine of an angle, we take the adjacent side divided by the hypotenuse. And to calculate the tangent of an angle, we take the opposite side over the adjacent side. So in this particular example, we have this right triangle. And this side right here is the hypotenuse. So we don't know the hypotenuse. So if we're considering our trig functions over here, the sine, to calculate the sine of an angle, we need to know the hypotenuse. And to calculate the cosine, we also need to know the hypotenuse. So that's kind of a dead giveaway that we must have to use the tangent in this particular example, because that involves a calculation that does not involve the hypotenuse. So what we can do is we can say the tangent of 53 degrees, so let's write that. Tangent of 53 degrees must be equal to the opposite side. So the opposite side of 53 degrees is this H right here, over the adjacent side to the angle. So the adjacent side is 12. So this is what we can write. So now all we need to do is solve for H, the height of the flagpole. So how can we do that? Well, we can start by multiplying both sides by 12. So we can say 12 times the tangent of 53 degrees. And when we multiply this right-hand side by 12, this 12 in the denominator goes away and we're just left with H. So H is going to be equal to 12 times the tangent of 53 degrees. Well, it turns out if you punch the tangent of 53 degrees into a calculator, you'll get about 1.327 is equal to H. So 12 times 1.327, that turns out to be about 15.924. And remember, the units we're using is feet. So the height of this flagpole is about 15.924 feet. All right, let's try another example. A woman is standing on top of an observation tower that is 100 feet tall. She measures the angle of depression to a rock on the ground to be 28 degrees. How far is the rock from the base of the tower? So let's draw the situation. If we have some tower here, and we know that it is 100 feet tall, and the angle of depression, it says, to the ground, to some rock on the ground, is 28 degrees. Now, angle of depression is a little tricky, and this is where a lot of people get messed up. The 28 degrees is not right here. It's 28 degrees relative to a horizontal line drawn from whatever object you're on top of. So this angle right here is 28 degrees to the ground. So the way that we're going to form our triangle is we'll draw a line straight up to whatever horizontal line is at the top of our object. So this angle right here will be 90 degrees. Okay, so we're told the height is 100 degrees, so that means this part of the triangle right here would be 100. We want to know how far is the rock from the base of the tower. So we want to figure out this distance right here. So let's call that x. Well, notice that this horizontal line must be equal to this horizontal line up top here. So here's the triangle that we're going to work with. We have a 28 degrees right here, a 100 is the side length of this triangle, and we're trying to figure out what is x. So how can we solve for that? So once again, we're going to think about our SOHCAHTOA. our acronym that describes our trig functions. So in this particular case, the hypotenuse of the triangle is right here. And once again, we don't know the hypotenuse. So it looks like we won't be able to use the sine or the cosine because both of those involve the hypotenuse. So it looks like, again, we're going to use the tangent as our calculation. So we'll say the tangent of 28 degrees is equal to the opposite side divided by the adjacent side. So the opposite side of our 28 degrees we know is 100. The adjacent side we don't know, this x right here. So we'll write x. So now we just have to solve for x. So let's get x out of the denominator by multiplying both sides by x. So we'll say x tangent 28 degrees is equal to 100. And to get x all by itself, we can divide both sides by the tangent of 28 degrees. So x will be equal to 100 divided by the tangent of 28 degrees. So if you punch tangent of 28 degrees into a calculator, that turns out to be about 0.5317. So we get 100 divided by 0.5317. And if you punch that into a calculator, you'll get about 188. And remember, our units is feet. So the distance from the base of the tower to this rock over here is 188 feet. All right, let's try one more example. Doug is flying a kite on the beach at the end of a 60-foot string. The angle of elevation to the kite measures 75 degrees, and Doug is holding the kite 5 feet off the ground. How high above the ground? All right, let's try one more example. Doug is flying a kite on the beach at the end of a 60-foot string. The angle of elevation to the kite measures 75 degrees, and Doug is holding the kite 5 feet off the ground. How high above the ground is the kite? So let's draw the situation. Doug is flying this kite that is on a 60-foot string. So we'll say 60 feet. So 60 feet is the length of the string. The angle of elevation to the top of the kite is 75 degrees. So 75 degrees. And Doug is holding it 5 feet off the ground. So here's Doug over here. And we know that Doug is holding it 5 feet off the ground. So we want to figure out how high above the ground is the kite. Well, if we call this distance from Doug's hand to the top of the kite x, the height of the kite is going to be, let's write height is whatever x is plus 5, since Doug is holding it 5 feet off the ground. So we just want to focus on this triangle right here. We want to solve for x, and at the very end we'll just add 5. So once again, if we think about our SOHCAHTOA acronym, which describes how to calculate sine, cosine, and tangent of angles, if this 60 is our hypotenuse, then it looks like the x is the opposite of our angle, of our 75-degree angle. So we have O and H. So it looks like we're going to use sine in this case to calculate the opposite over the hypotenuse. So let's do that. Let's say the sine of 75 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 60. So now we just need to solve for x. So if we multiply both sides by 60, we get 60 sine 75 degrees is equal to x. So if we punch in 60 times the sine of 75 degrees into a calculator, we'll find that x is roughly equal to 57.95. And remember, we said the height of the kite is going to be whatever x is plus 5 additional feet, since Doug is holding it 5 feet off the ground. So the total height is going to be equal to 57.95 plus 5, which is 62.95, and we'll say feet. The kite is 62.95 feet off the ground.